Hi, let's do an example about vertical circular motion. So since you have done the looping the loop video earlier, then you should be able to do this. So pause the video now, try it out, and I'll show you the answers later on.
A few moments later.
Alright, so the first thing that you want to do is to draw a diagram, as always. And so the question asks you about the lowest and highest point. So let's label it. Draw the object maybe. And so there is a string that's connected to it. Next, very likely you need to draw the free body diagram at two positions. So for you at the bottom, you have weight and you also have tension. So T here. Notice that it's performing circular motion. So once again, there should be a net force pointing towards the center. So here at the bottom, you should have the tension greater than W in order to have the net force that pointing towards the center. As for the top, then it doesn't really matter a lot, right? So W and tension. Okay, so let's just try to express for the two different points. So maybe we can do at lowest first. Then we can do F equals to MA for centripetal acceleration and centripetal force. And so we can have T minus W equals to MA, which I guess since they provide us R and V, so then we can do V squared over R. And at most you can change W into mg. And I think that's all we can do. As for the highest, then we can write the same thing again, F equals to MA. Then this time is both of these two forces, tension and weight, will be acting like all together, acting as a centripetal force. So then mv squared over R. So for this V, let's just distinguish them. This V should be at the lowest. This one should be at the highest. So VL, VH, I guess. Alright, so in part B, it's asking you the minimum speed. So in fact, the question didn't tell us any numbers, so you have to find an expression, in other words, so that the string never goes slack. Okay. In fact, you don't have to care about at the lowest, because even if you don't do anything vertically, like at the bottom, the string is always never goes slack, it's always tight, right, no matter what happens. So you don't actually have to think about this, you just have to think about at highest, because when you are at the highest, then you have to care about when the string never goes slack, that means the tension will be bigger than 0, right? Because when the string goes slack, that means tension is 0. So that means as long as tension is bigger than 0, then it is okay. So that is to say, you can say, then for part B, then you can say T is bigger than 0 when it's not slacking. Then T plus W is bigger than W. That is to say this thing itself, and that is to say MV at the highest point is bigger than the weight. Alright, and then you can have mg here. M will cancel out, and so that is to say V at the highest point would be equal to G times R over, okay, nothing, just GR, alright, with the square root. So this is the speed that you will have at the top. However, we are trying to find out the minimum, and so the minimum will be barely equal to this. Okay, so barely equal to root GL. So, well, depending on what kind of string you have and also what planet you are, then you can substitute into G and L. So this is the expression for the minimum V you need to reach at the top. Alright, so we finished up this example already. However, I would like to give you a bonus question. So listen up. My bonus question is that this sample question is actually faulty, because according to the physics, if you have a string with a mass connected and trying to perform a vertical circular motion, you would never obtain a constant speed. So that is to say, your vertical circular motion would never be uniform in this setting. Can you think of the reason why? Pause the video now.
2,000 years later.
The reason is actually very simple. Think about the other position in this circle other than the top and the bottom. For example, like here and the right, okay? And so the string will be like this, and you will have the force, which is tension, along the string. Okay, tension is always along the string. So this is the direction you can have, which is pointing to the center, which is good. But then think about the weight that you have. It's going to point downward. So in this case, think about this. There's no way you can balance the force to get to just to have the centripetal force going towards the center with the net force. So in this case, you cannot really obtain a uniform vertical circular motion. That applies the same when you add here, for example. You can also see that the tension will be pointing to the center, but then the weight is going down. So once again, you can never balance it. And so you may ask, does that actually mean vertical circular motion can never be uniform? The answer is no, it can be uniform. Let me give you 10 seconds to think about in what situation it can be a uniform vertical circular motion. The answer is when you have, instead of a string, you have a rigid body. Okay, rigid body means it could be a rock that is perfectly hard in physics. So let me show you an example. So imagine instead of you having a string, once again, you just have a stick, and that stick is going to connect it or mount it with a mass, and so these can perform a circular motion. Okay, and not to mention, of course, at the top and at the bottom it is fine according to what you learned in this question, but then also at the side as well, because if you think about, hey, then isn't the tension or whatever force also be going along the rock? The answer is no, right? It is not necessarily for the rigid body like a stick to have the tension or the force going towards or along the stick direction. So what you could have is you could still, of course, the weight was still pointing down, but then think about the connecting part, like the area, like this area here. So what you can have instead for adding onto this object is it may have a reaction force that is going in this direction instead. So at the end of the day, what you have for the reaction force going in this direction and the weight going down is having a net force that is pointing towards this direction. So you can take it as in this reaction force will have a vertical component that is equal to the weight, and so in that case you can then only have the horizontal force going towards the center, and that is the same when you are at this position, having the weight going down, weight W, and then you could have the reaction force that could be going in, say, this direction, and so the net force would still be going towards the center. So this is something that could happen only when you are in the rigid body, because of the force can't go without going in the same direction of the stick itself. This concept was actually asked in the past exam, and so you can find it in the past paper, and back to that year this question actually killed a lot of candidates, and because people didn't know about this. And so I actually have made a video called the hardest IB physics multiple choice question ever, which I'll put a link in the description below. So you can also find in other topics what are the other MC, and also you can try this out by the way. What are the most difficult questions in history? So here you have it. Now you understand more about vertical circular motion. I hope you enjoy learning physics with me. If you do so, please hit the like button and subscribe to my channel. I'll see you again in the next video. Bye.